Sure. Okay, so this is 2 questions. We'll take them one at a time. So in general, actually, let's generate a nice looking graph so it'll be a little bit easier to describe. So let me create a nice looking graph here and copy and paste it in so I have like a visual, because I feel like this is a very visual question, right? You're asking like I can't even look at it and kind of make heads or tails of what that is. So let's look at, say, this picture here. So there are lots and lots and lots of periods here. So a period is just basically one non-repeating section of the graph. So for example, if we started looking for a period, say, beginning with this point, basically I'm going to look for one non-repeating section. So the graph goes up, goes back to the x-axis again, and then it would do another up and down section. So like that part of the graph is like one cycle. Okay with that? So the period is the x-axis length that we're talking about. So in this case, if we're going 0 to 0.5 pi, we'd say that the period here is just pi over 2. But you can really measure your period starting from anywhere, right? You could start from like this maximum back to that maximum. That's still going to be one period. It would still be the same length. So that's all we mean when we talk about a period. Does that visually, does that satisfy what you needed? Okay. And then you had a second piece, right? And this was graphing related, it sounded like? Yeah. So if we were looking at worksheet 1, that was the graphing one, right? Yeah. Okay. Do you have a particular problem on there that we can talk about so we have a little bit of context to it? Okay, sounds good to me. Usually makes life easier if we have like a specific thing that we're talking about, right? Okay. So, and this was related to like putting points on the graph specifically, I think, right? Okay. So let's just generate the transform coordinates for this real quick, and then we'll talk about how to plot those and extend the graph or whatever. Sound good? Okay. So I would start by just listing my values for A, B, H, and K. Because I'm going to use those to create my transformation map. Is that all okay there? All right. Since this is a cosine function, I'm going to use the key points for cosine. And now I'm just going to plug in these key points, those x and y values, into that map that I wrote just a moment ago. So 0 plus 3 pi over 2, just 3 pi over 2. 1 times negative 2 is negative 2. Pi over 2 plus 3 pi over 2 gives us 4 pi over 2, which is just 2 pi. And then 0 times negative 2 is 0. Pi plus 3 pi over 2 is the same thing as like 1 plus 1.5. So it's like 2.5. So you could write it as 5 pi over 2 is the same thing as 2.5. And then -2 times -1 is +2. And then 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, or just 3 pi. And 0 times -2 is 0. And then 2 pi plus 3 pi over 2 is like 2 plus 1.5, so it's like 3.5. Or 7 pi over 2. And then -2 times 1 is -2. Okay with how I did that, Elizabeth? Okay. So now if I'm looking at trying to plot these things, I notice that these minor grid lines here that are unlabeled, if this is 0 to pi, halfway in between must be like pi over 2, right? So this is like pi over 2 here. This would be like 1.5, so 3 pi over 2. This would be like 2.5, so that's like 5 pi over 2. That's 3.5, so it'd be like 7 pi over 2. Does that make sense? And how I kind of just visualize that out? Okay. So if I start plotting then, 3 pi over 2, -2 is there. 2 pi, 0 is there. 5 pi over 2, 2 is there. 3 pi, 0 is here. And 7 pi over 2, -2 is here. Okay with that. And I'm just going to kind of extend this pattern. So after we got to the minimum, we would go back to the x-axis. And that's as far forward as I can extend, because now I'm out of graph. But we can extend backwards. So before I got to the minimum, I would be at the x-axis. And then I would go to my maximum. And then I go back to the x-axis. And then I go to my minimum again. So just kind of following that same pattern, right? Is that okay? And then I'll just kind of connect my dots, trying to be as neat as I can. Easier said than done on the tablet, but so something like this. Does that feel okay, Elizabeth? Okay. Did I feel like I answered your questions there in terms of? Okay. So usually, to sum this up, when I'm thinking about these coordinates involve pi, if everything involves pi, you can just kind of forget about the pi's and think about it as like, oh, that's 1.5, 2, 2.5, 3, 3.5, 4. And pi is just like an arbitrary unit we've tucked on there. But it doesn't really make much of a difference when it comes to plotting it if everything has pi's in it. Does that help a little? Good. So who else had their hands up? Oh no. I should know. Lauren? Yes. Number 6 from homework. Oh, homework problems. Okay. Yes, sure. We have so many number 6s, it just had to sit there and think for a moment. Okay. So again, I'm going to start this kind of the same way we did the previous one. So I'll identify the values for A, for B, for H, and for K. Are you happy for everything that I've come up with there? You're good with why the B is 1/2? Okay. So then I'll write my map. And then, because this is cosine, again, I'm going to use the key points for cosine, which were the same key points we did for Elizabeth's question. And now I'm just going to kind of push those through. So 0 times a half is 0. 1 times negative 3 over 2 is just negative 3 over 2. 1/2 times pi over 2 is pi over 4. And 0 times whatever is 0. Pi times a half is pi over 2. Negative 1 times negative 3 over 2 is just 3 over 2. 3 pi over 2 times a half is 3 pi over 4. And 0 times anything is 0. And then 2 pi times a half is just pi. And 1 times negative 3 over 2 is just negative 3 over 2. Hi, Victoria. So let's go ahead and graph this. So I'll just kind of import myself a XY axis that I've already made and labeled out here. So the tick marks there, Lauren, every tick mark is a half a unit of pi. So we can plot that then. So I have 0 and then negative 3.5. Pi over 4, which should be halfway between 0 and half a pi, right? Like a quarter is in between 0 and a half, midway between. You agree with that? Okay, and then we have pi over 2 and 1.5, and then 3 pi over 4, which would be halfway between a half and 1. And then pi and negative 3 pi over, or 3 over 2. Come in. And then we just kind of extend this out in both directions, following the pattern. Thank you.
You're welcome.
And I'm just going to go in one direction, Lauren, if that's okay. So half of our graph would look like this. Does that feel okay? It was just going to be longer then. Yeah. So, yeah, that's a decent point. I missed that. So really, I guess what you'd want to be using is a graph paper that looked like this. They went all the way to negative 4 pi to positive 4 pi. And you're just doing the same thing. You're just extending in both directions. So you have lots of them, lots of cycles. Is that okay? Are you sure? Okay. Elizabeth? Worksheet 2. Okay. So here we're asked to construct a sinusoid. That means we're going to write like a sine or cosine function, like y equals or something or another. Okay with that? And we're told some information about the amplitude. So we know that the amplitude is the same thing as the absolute value of A. Or really then that A has to be either the negative or positive version of square root of 6. Okay with that? We're told that the period is 7 pi over 6. So I know that the period is equal to 2 pi times the absolute value of B. So if 7 pi is equal to 2 pi times the absolute value of B, if I divide both sides by 2 pi, the pi's cancel out, and I'm left with just 7 over 2. So B is 7 over 2 or negative 7 over 2. Okay with that? So because I'm working with a midpoint here, I would use the sine function instead of a cosine function. If I'm given an extrema like a max or min, I would use a cosine function. Not that you have to do that, but it makes finding the h ever so much easier if you do that, which is really the trickiest thing typically to find, is that value for h. So if we're going to use a sine function, in our parent function, sine has a midline point at 0, 0. And we're going to transform that midline point to the new midline point of 4, 18. So remember, what happens is that we take our b, we multiply it to the x from the parent function, plus h. That should give us the x in the transformed function. Right, when we're graphing, that's the transformation map we use. So in this case, we'd have b times 0 plus h should give us 4. Now, it didn't matter what the b was here because we're multiplying it by 0. So we just have that h is 4. Is that okay, Elizabeth? And then we can do the same thing with the y coordinates, right? A times, the y coordinate from the parent plus k should give us the y coordinate for the transform function. And again, because the y coordinate was 0, we can see immediately that the k should be 18. So now we just need to make a decision about whether these a's and b's should be positive or negative. Now, here it doesn't matter because we're not given enough other information for it to matter. So whether we pick the a's or b's to be positive or negative, they're still going to satisfy the requirements of this problem because all we need it to do is pass through this point. That is going to happen whether those a's or b's are positive or negative. So just to kind of illustrate this, what was it, 418, was that the point? Do you remember? Yes, okay. Where's my graph? Oh boy. Oh, I see. I know why. Dirt, 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 dirt. So there's the graph when both A and B are positive, right? And here's the point. 418 is right there. Let's make it a more obvious color. Now, let's say that just A was negative. Now, the graph looks different, but it's still passing through that same point. Let's say that both A and B were negative. We're back to the original. Still passes through that point. What if just B was negative? Still passes through that point. So it didn't matter as far as our answer. The amplitude and the period didn't change when we changed the sign on A and B. And it still passed through that point, 418. So any answer, any of those 4 answers that we just described would have been appropriate, would have been received full credit. So it didn't really matter for this problem whether the A was positive or negative or the B was positive or negative. Did that help? Okay. Sure thing. Anybody else? Happy to do more if you guys have more, but if you don't, that's okay too. Elizabeth? Sure. Do you have a preference? Sure. Okay. So again, same kind of idea. Here we're asked to do it both, give both versions, the answer that uses a sine and the answer that uses a cosine. For any of these problems, that's always going to be possible. You can always give two answers. Although certainly for most of these problems, if you're just given information, one answer is usually much easier to come up with than the other, but it doesn't mean that it's wrong to give the other version. So what I would do first is I like to find the value for k, because I can do this without having to do any calculation. I'm just going to use my eyes. So k is that midline point, so it should split the function basically in half. So I can see that the k value is 1 right away. Elizabeth, are you okay with that? Okay. And the amplitude then is just the distance from a max or a min back to that midline. So again, without having to do really anything more than some counting, I can see that the amplitude is 2, so the A is either positive 2 or negative 2. Then I'm going to find the length of a period, so I can calculate the B. What I find when I'm given the graph, usually the easiest thing to do is to go from extreme to extreme. So if I go from minimum to minimum, the period would be 5 pi over 2 minus pi over 2, which is just 2 pi. Are you okay with that? Then I'm just looking at how far that distance is from the one minimum to the other, measured on the x-axis. So knowing that, I can see immediately that b is either going to be 1 or negative 1. Since the period is 2 pi and the period is 2 pi times b, or the absolute value of b, b had to be either positive or negative. Okay there. All right. So now if we're doing sine, what kind of point would I want to use to find the h value if I'm doing a sine graph? I want a midline point. So the midline point that I'm given on the picture is pi comma 1. So if I use that, I can say that h is just going to be pi. Again, using the same reasoning that we talked about earlier, where because the x-coordinate is 0 on the midline point, the new x-coordinate on our transformed is just going to be pi. But I have to be careful here, because now the sign on A or B matters. So let me explain why. So when we graphed the parent function for sine of x, we go from a minimum to that midline point of 0, 0 to a maximum, right? That's the kind of the order that goes on. Here, we're going from, in our transform function, we go from minimum to midline point to maximum. So there is no reflection going on. It's still the same order. Do you see that? Had we instead chosen this to use as our midline point, there the A would have needed to be negative, or the B would have needed to be negative. One of the two needed to be negative, but not both. Is that okay? Okay. So that's all we need then. So we have y equals positive a sine positive b x minus h plus k. Now for the cosine function, I'm either going to use a minimum or a maximum. It doesn't really matter. You can use either one. For the sake of argument, let's assume that we used the minimum. So again, that tells me right away the h value is just pi over 2. Again, it's just going to be the x-coordinate of our transformed function. But here, again, the sign of a matters, right? So, again, to explain why, our parent function for cosine looks like this, where we start with a maximum. In the graph that we're looking at here, we started with a minimum. That tells me that the a needs to be negative. Now, had we instead used 3 pi over 2 comma 3, we could have written our answer that way. That's also correct. So because you used a maximum, the a value needs to be positive there. Is that kind of help, Elizabeth? So the trickiest thing really in doing this is making sure you have the correct h value and that the sign on your a matches up. On these ones where you're given the entire graph, you're always going to have to be careful about your signs. There it will always matter. On some of these problems where you're just given a little bit of information, sometimes it matters, sometimes it doesn't. So like on number 5 that you had asked about on worksheet 2, it didn't matter whether we picked positives or negatives for the A's and the B's. Other problems on worksheet 2, it does matter. Nothing or everything on worksheet 3, it will matter. So you have to be a little bit careful there, that sometimes it makes a difference and sometimes it doesn't. Does that feel okay? Okay. Let's take a break here. We'll move on here a little bit to new material. Not tremendously new, because it's still the kind of the same idea. But we should move forward, limp forward here a little bit. So today, what we're going to talk about is graphing the tangent function. Hello. Thanks. Can you just set it right there on that desk? Would be excellent. Thank you.
Thank you.
You're welcome. Okay. So what we're going to do is we're just going to start with a little bit of a information dump. So if we have the parent function for tangent, it's just y equals tan x. The domain let's just write this down. We'll explain why we're getting these odd results here in a moment. So this is the first trig function that we've seen that's not everywhere continuous, right? We have some discontinuities going on here. We'll show you why in a moment, why that's happening for tangent. The big thing, though, the place where I see those students making the most mistakes is forgetting this, that the fundamental period for tangent is not 2 pi, like it is for sine and cosine, but rather just pi. I see that frequently, that students forget that. Again, when we show you why there's discontinuities here for tangent, we'll also point out to you why the period is pi instead of 2 pi. But it's pretty obvious once we start kind of doing the construction here why that's going to happen. Everybody okay? So to kind of demonstrate this, we're going to go back to the unit circle and draw the graph for tangent using the unit circle, just like we did at the very beginning when we use the graph or use the unit circle to draw our graphs for sine and cosine. Oops. Okay. So let's zoom into that unit circle, and we'll kind of show you how we get this stuff. I'm going to make that XY axis a little smaller here so I can see it at the same time as the unit circle. Okay. So remember that tangent of theta is equal to y over x, right? That was our unit circle definition for tangent. So if I go and I look at tangent of 0, that's going to equal y over x, so 0 over 1, which is 0. So there's a point. Tangent of 0 gives me 0, so the point 0, 0. Everybody okay there? If I then go, say, to tangent of pi over 4, that is going to be square root 2 over 2 over square root 2 over 2, which is 1. So pi over 4 and 1 is there. And then say we do tangent of pi over 2, which is going to be y over x, and 1 over 0 is undefined. Now you saw last year in Algebra 3-4 course, when we get a 0 in our denominator like this, it creates a vertical asymptote, right? When you talked about rational functions, you saw that happen? Does that ring a bell? So we'll draw in our vertical asymptote. And we know that for the vertical asymptote, the graph is just going to kind of follow that. Going on forever, right? So far, so good? Okay. If we go then to tan of, so we did that one, 3 pi over 4, that's going to give me negative root 2 over 2 over positive root 2 over 2, which is just negative 1. And then if we do tangent of pi, that's going to be y over x, so 0 over negative 1 or 0. And then if we do tangent of 5 pi over 4, that's going to give me negative root 2 over 2 over negative root 2 over 2, which is positive 1. And if we do tangent of 3 pi over 2, that's going to give me negative 1 over 0, so I have another asymptote. If I connect these pieces, again, follow the asymptotes to draw our line. Yes, Elizabeth. Well, because any other point here is going to correspond to a point on tangent, right? Like any angle measure I can find in between here is going to correspond to some point on the unit circle, so I can connect all these things together in between the asymptotes. The asymptotes are the only place where I have the jumps. I just needed to get enough points in between to kind of get a picture of what's going on in between. Is that okay? Just like when we did sine or cosine, we didn't do everything on the unit circle. We just kind of picked the quadrantal ones, the multiples of 90 degrees, where the maximums and minimums are occurring. Now, there is no maximum or minimum on tangent because it has these infinite discontinuity. So we just needed to pick something else in between to get an idea of whether it's going up or going down before the asymptote. Is that okay there? Yes, it does look very different than the others, absolutely. So if we continue, So tangent of 7 pi over 4, again, is going to be y over x, so negative root 2 over 2, or negative 1. And then back here now to 2 pi is going to be 0 over 1 again. And you can see now, hopefully, that if we did another one, we'd be up here, and we'd be getting another one of these with an asymptote out here, right? So basically, this thing represents one period. Lauren? Mm-hmm. Yes, yes, yes. 100%. So again, what Lauren asked there, if you missed it, was that we're getting an asymptote every time the y coordinate is undefined. 100%, yes. So this is one period, right? And you'll notice that that's pi long. The distance from pi over 2 to 3 pi over 2 is pi. Should have probably written undefined there. Everybody see that? And then we notice that if that's the case, and this is periodic, that if every pi units, we're going to be getting another undefined piece. So if we have pi over 2, 3 pi over 2, the next one would happen at 5 pi over 2, and then 7 pi over 2, and then etc. So that's why our domain is everything except for where those asymptotes fall. Right? That's why the location of our vertical asymptotes, our infinite discontinuities, is also at that same location. So what we take away there is we can use this then to come up with our key points list for graphing tangent. Now you'll notice that when we did this, we have this period here that I highlighted, right? Typically when we list the key points, we're going to use that period here. And the reason we do that is we want the origin as one of our key points. So when we start translating back and forth between the graphs, we have access to that 0, 0 point, because it makes finding h's and k's really easy. So that section there in green is the one period that we're going to use for our key points. Oops. So those are the 5 key points that we're going to use to graph our tangents. And also when we write the equation for tangent, when we figure out our h and k, those are going to be the 5 key points that we'll draw from. So let's do an example. So let's say we wanted to graph this function here. So I would start by listing my values for A, B, H, and K. So A is -2, B is +2, H is π/4, and K is 1. Elizabeth? Of course. Everybody's okay with how I came up with those values? Okay. So I'll write my transformation map. So I have Bx plus H, and then AY plus K. And then I'm going to take my key points from before. And we're going to perform our transformation on those key points. Okay. So 2 times -π/2 is -π, and plus π/4 is -3 π/4. And anything you do to undefined stays undefined. 2 times -π/4 is -π/2. If I add another quarter to that, that's -1/4 pi. And then -2 times -1 plus 1 is 3. If I plug 0 in, I just have π/4 and 1. If I plug π/4 in, 2 times π/4 is π/2. If I add another quarter to that, that's 3/4 pi. And then -2 times 1 plus 1 is -1. And then if I plug in π/2, 2 times π/2 is pi, plus 1/4 is 5 pi/4, or 1 1/4. And anything you do to undefined still stays undefined. So to graph this, then, I'll put in some graph paper. So that's just from -2 pi to +2 pi. So I like to start by drawing in my asymptotes. Asymptotes begin at -3/4 pi and end at 5 pi/4. Whoa-sy daisies. Okay, come on now. So those are my asymptotes. Everybody's okay there? And now we'll plot the rest of them. So I have -1/4 and 3. And then I have +1/4 and 1. And I have +3/4 and -1. So it looks kind of like that. And then I'll try to extend this back out. So I'd be at +1.75 and 3. And then I'd be at +2.5 and 1. So So I'd have like that part of it. Then over here I would be at negative 1 1/4 and negative 1. And then negative 1.75 and positive 1. And then negative 2 1/4 and 3. So I'd have like that as my other piece. Is everybody okay with what I did there? Same idea as before, just like a slightly different shape, right? Okay. The last thing I want to talk about in this section is going from a graph back to an equation. So the same kind of thing that we had done before. Oh, it's so little. Let's make it big. Okay. So just like when we did this for sine and cosine, what I need to do is figure out the values for a, h, and k, or a, b, h, and k, excuse me. I like to start with the k because I can do it just visually. So again, the k is the midline point. It's like the average value. So there's my midline. Everybody okay with the reasoning there? Looks like I have an equal section above and below the graph, right? So that distance between the midline point to that next point up there is my amplitude. Is everybody okay with how I came up with that? The distance between my asymptotes is my period. Now remember that for tangent, unlike sine or cosine, the period is pi times b instead of 2 pi times b. So hopefully it's easy to see there that b would have to be positive 1/2 or negative 1/2. Is everybody okay there? And then the last thing I need to do is figure out the h and then the sign for my a's and b's. Everybody's okay with that? So I'm going to always use my midline point. So for tangent, my midline point is at 0, 0. And in my transform point, it's going to be 0, negative 1. Well, that's going to tell me immediately that h is 0, right? But I also need to determine the sign of a here. So remember, for the parent function for tangent, the graph kind of looked like this. So we had the down arrow, then our midline point, then the up arrow. You guys see that? Where I had down arrow, midline point, up arrow as we read from left to right. If I look at the transform function, I have the down arrow, midline point, up arrow. So what that tells us is since those are the same order, that the A is positive. So that's everything I need. And again, you could simplify that up a little bit, but I don't. When I write the notes, I usually just leave it with everything kind of written out in its place. So if you go back to look at it, you're not confused as to what's going on. Let's do one more. And then we'll be done with the notes here. Okay. So again, start with our K. Everybody's good with that? And then we'll find our A. Oh, I'm dumb. I didn't look at the scales at all. That should be 3 or -3. Try again, dummy. Right? If I'm going from 2 to 5. Is that okay? All right. And then if I want my period, so that's going from -pi to 0. So that's just pi. Everybody's okay there? And then to find my h, I'm going to take my midline point. So from the parent function, our midline point is 0, 0. And remember the order for the arrows were down arrow, midline point, then up. In our transform function, the midline point we're mapping to is -pi/2, 2. And the order of our arrows here are up, midline point, and then down. So that tells me that h is -pi/2, and because the order of my arrows are opposite, that the a needs to be negative. So y equals -3 tangent of 1/1 x minus a -pi/2